Hello everyone, welcome to my channel Mathematical Ecosystem. In this class, we will discuss geometrical interpretation of differentiability. Before going to the topic, let's have a look on basic concept of lines. Okay. Look, we consider a line. Okay. These lines makes an angle with the positive direction of x-axis. Okay. This angle is called angle of inclination. That's mean the line inclined at an angle with the positive direction of x-axis. This is the angle of inclination of this line. Okay. Now, going to the slope or gradient of this line. Tangent of this angle is called slope or gradient of this line. This is in generally denoted by m. Then the equation of the line is y minus y naught equals m into x minus x naught, where p x naught y naught be a point on the line. Okay. So this line is passing through the point p x naught y naught, and psi is the angle of inclination. So tan psi equals m is the slope or gradient. Then the equation is y minus y naught equals m into x naught. This is the basic on line. Okay. So back to the main topic. Look, here we consider a curve y equals fx. Okay, and took a point p x naught y naught on the curve. Okay, just drawing a tangent at p, which make an angle psi. Okay, this is with the positive direction of x-axis. This is the angle of inclination of this tangent. Okay, now differentiability means this nothing but the equals to the slope of the tangent at p x naught y naught. Okay, so as psi is the angle of inclination of this tangent, so tan psi is the slope. Okay, so dy dx at x naught y naught is nothing but the tan psi. Okay, but we know that dy dx, that is f dash x at the point x naught y naught, is denoted by f dash x, and it is defined by the limit x tends to x naught fx minus fx naught by x minus x naught. Okay. Now if limit exists, then limit is always unique. Okay, so differentiability means if you have a limit and which is unique. Okay, and limit unique means, look, this value is unique, so that's mean your tan psi, that is dy dx at x naught y naught, that is tan psi, let's say this is m. Okay, as it is slope, it is generally it is denoted by m. Okay, so what will be the equation of this line? Tangent y minus y1, sorry, y0 is equals to m into x minus x0. Now your gradient m is unique, and also the point x naught y naught is also unique. Okay, so the equation of the line is unique. So you find an unique tangent. Okay, so we have differentiability means unique tangent at that point. Okay, so we find that unique tangent is the necessary condition for differentiability. Okay, so that's mean when you find more than one tangent of a curve at a point, your curve will be not differentiable at that point. Okay, so for example, look at the graph of mod x. You know this is the graph of mod x. Look, we can draw infinitely many tangent at origin. Okay, like that. You can draw infinitely many tangent at origin. So that's mean you can draw more than one tangent. So tangent at origin is not unique. So that's mean your function is not differentiable at origin. You can also verify by the left hand derivative and right hand derivative also. So it is not differentiable. Okay, at x equals 0. Okay, so fx equals mod x is not differentiable. So now next question is, look, is unique tangent is the sufficient conditions for differentiability? Yes or not? We find that unique tangent is the necessary conditions for the differentiability. But next question, is this sufficient one? Okay, for this example, just consider the functions y equals x to the power 1 over 3. Okay, okay. So then, look, this is the graph of y equals x to the power 1 upon 3. Okay, and look, at origin y-axis is the tangent. Okay, this is the only tangent at origin and which is vertical. Y-axis is the vertical line. Okay, so you find unique tangent at origin. Now coming to the differentiability. Okay, so if y equals x to the power 1 by 3, then dy dx will be 1 over 3 x to the power 2 by 3. Okay, so as x tends to 0, your dy dx tends to infinity as x in your denominator. Okay, so that's mean your dy dx not have finite values, so that's mean your function is not differentiable at x equals 0. Okay, so we find the answer that of the questions that unique tangent is the not the sufficient conditions for differentiability. In this case, we find a unique tangent of this function at origin, but its function is not differentiable. Why not? Since the tangent is vertical. Look, your what is the angle of inclination of the tangent? The angle is here psi is 90. So what is the value of slope at the point of this tangent? M equals tan psi, right? And psi is 90, tan 90, and we know that tan 90 is undefined. Okay, so how can we find dy dx? Because m is nothing but dy dx. Okay, so m is undefined, that's mean your function is not differentiable at that point, although it has a unique tangent at that point. Okay, so more than one tangent at a point, your function is not differentiable. Vertical tangent, your function is not differentiable. So find the result that differentiability at a point means you have a unique tangent and also you have a non-vertical tangent at that point. Okay, so that's mean this is a smooth, your curve is smooth, so your curve will look like that. Okay, if you have your curve will look like this corner point. Okay, this is called serve point or corner point, or serve point, then your curve is not differentiable, at that point. Okay, so this is the geometric interpretation of differentiation. That's all for this video. If you have any doubt, ask me in the comment section. Thank you.